Hello everyone and welcome to a new stream. Today the stream suddenly interrupted while I was resting because it started raining outside and my connection wasn't the best and the stream then crashed. Also, let me just do something real quick to prevent my stream to crash. Let me just do something real quick. Okay, I might get a huge lag, but that's temporary. Let's switch right now. Okay. Uh, wow, it didn't impact my connection. That's nice. So let's keep learning Rust, right? We're following the guide. Also, they have a Discord server, right? That's cool. And they have the Rust programming language server, and I don't know. Yeah, I can allow that. And this, oh god, this looks a bit communist. I'm not gonna lie. And yeah, okay, that's cool. And then we have 60,000 members. Wow. And then we have like the okay. We also have the LGBTQ plus flag here. I don't know what is it Pride Month? Uh, it's not Pride Month yet. It's actually in like 2 weeks. Yeah. So let's join this server. And this is very like this is the community, right? And okay, let me just um that's the announcements channel. It should be here, right? Yeah. Welcome to the official wrestling Discord. Okay. Let's read that. What is this? Oh my god. This community actually has rules. Like it's like a controlled community, right? So these are pretty basic and common sense rules. Um, I will exclude you from interaction if you insult. Okay, that's obvious. We shouldn't harass or insult anyone, no matter what they do. Actually, it kind of depends, but private harassment is also unacceptable, no matter where you are. If you feel you have been harassed or made uncomfortable by a community member, please contact one of the channels. Okay, so this is not just the inner rules. Like this is they accept decent people. Okay, so if you are a, a piece of shit, even outside of the community, they might kick you, right? Uh, okay. Please keep unstructured critic. If you have so idea you want to experiment, make it work and see how it works. I don't understand this rule actually. Please keep unstructured critique to a minimum. If you have solid ideas you want to experiment with, make a fork and see how it works. Respect that people have differences of opinion and then okay. Being mean or rude. Please avoid using okay. I don't know why I read the bottom two up in this way, but okay. Oh, this is there is also actually okay. Oh, that's oh wait, with a warning. So this is related to Discord, right? Because I basically I don't know. I don't know. Out of the communication channel. It's not just Discord, but it could be anything. So that's pretty cool, right? Let's go to Discord. So this is I don't know what to do now. We have the general. Oh, I must complete something. Yeah, I already agree this. I already agree. If you see someone behaving inappropriately or otherwise against the code of conduct, please contact the mods using mods or by DMing a mod from the sidebar. Okay. So this is pretty much how it works. Like we have members here. Uh, I don't know how everything works actually, but I'm new here. Like I don't know what to expect honestly. Uh, what the hell? So yeah, that's pretty much how it works, right? Right. Uh, what is pub? What does that mean? We also have a new keyword impl, probably from implement. This is probably an interface. I don't know. Uh, that's kind of weird. Then we have test. This this should be I don't know. Then we have a macro, and I honestly don't know what that is. Like I don't understand anything. This is so different. It's so different. Rust is so different. So, oh, we also have C3, and this is another language that is supposed to succeed C or C plus C plus plus. Yeah, C or C plus plus. One of the two. And also this is also interesting. This is the creator. And yeah, that's pretty much it. So let's go back here. So we have this type of stuff, right? And yeah, So, the last time we were reading the docs. Rust docs. This probably. And we were programming in guessing game. The thing we learned yesterday or 2 days ago. Wait. I think that was 2 days ago. Holy shit. We implemented. Wait, hold on. Why it's not syntax highlighted this? This should be highlighted because we are printing a variable right here. For some reason it isn't. Everything else it is. Cannot over anything. Let me just reopen the workspace. Let me just reopen this and let's see if that. Yes, we have a Rust analyzer, and I don't know. We still get the same result. I should be patient because the Rust analyzer is still running. It's a bit slow, I'm not gonna lie. Oh, I like this screen here. Oh, we also have Rust dependencies. It's empty. Wait, how did it get? What the hell? So yeah, okay, now everything works fine. We also have oh, this is what is this? This is all the all the installed dependencies. It's stored right here. Like I said the last time, it's in a global folder. But that's obvious. How cool is that? So, so I'm a beginner, honestly, and there are like it's pretty inactive. The Rust server is actually inactive because I don't know. Like we have many people. There are 60,000 people, right? So that's a macro. That's not a function. And I still don't know what that literal is. Like it looks like a JavaScript template argument, but this is a string format. Honestly, I'm still trying to understand what that is. Like it doesn't. It takes this this argtt. Then we have. Is this a pointer? This is probably pointer. I don't understand, honestly. Like what the hell? So we have this, right? But what does this mean? Like we also have a colon here. Like I don't understand, honestly. What is this? but we understood what a match is, and it's kind of like a switch case for with returning numbers. It's kind of weird. It's weird. You also have it's also we also have lambdas for each match. Like it looks like a switch case with calls and return values. It's weird. Do we have a switch? Wait, do we have a switch case? We don't. What? We don't have a switch case. Do we have a while loop? Yeah, we have this. And we have a do while. We don't. Wait, what? So this doesn't exist. So we cannot do this. So if I print this with a wait, I'm dumb. This isn't how it works. It should be like that. So if we try to run this, wait, I have to go to this folder. This is the guessing game, right? Oh wait, what am I doing? Guessing game. And then we run. We expected an expression, right? This is the found reserved keyword. Wait, what do you mean reserved? Wait, this is a reserved keyword. What does that mean? Like I cannot use this name, right? That's a reserved keyword. So we cannot name it like that. This is also deprecated, but I don't care. This is just an example. I'm just trying to understand things. Wait, what is this? Oh my god, you can actually... Wait, what? You can actually run and debug this. Oh my god, this is... Wait, what's the number here? It was 1. Like, wow. So, let's try to create something. Like, let's keep going with the tutorial. Like, we have common programming concepts. We have this. As mentioned in the starting values with variables section, by default variables are immutable. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. That's cool. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability, and why sometimes you might want to opt out. When a variable is immutable, once a value is bound to a name, you can't change that value. To illustrate this, generate a new project called variables in your project directory by using carrigan new variables. Let me just check what is going. Okay. And so we have the length of the array. Uh-huh. Oh, shadowed, or the scope ends. That's basically what C does. Like, honestly, in C and C++, you also have this concept of shadowing. Like, if the scope ends and you use the same name, it doesn't give you an error. Like, you can actually use the same name, but the name has to be in two different scopes. And honestly, this wouldn't be allowed, but this is allowed. Like, you can actually declare variables with the same name in two different scopes. Like in Rust, you can do it on the same scope, and I don't know if that makes sense. I don't really know, but yeah. But we also have constants. The thing that I don't understand is if the variables are immutable, what's the point of having constants? Like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. Yeah. First, you aren't allowed to use mut with constants. Constants aren't just immutable by default, they're always immutable. You declare constants using the const keyword instead of let keyword, and the type of the value must be annotated. We'll cover types and annotation in the next section, that's data types. So don't worry about the details right now, just know that you must always annotate the type. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of the code need to know about. The last difference is that constants may be set only to a constant expression, not the result of a value that could be computed at runtime. Okay. Yeah, we of course have difference between constants and variables, but the thing is, what's the actual difference? Like, what the hell? So let me just. So I really don't understand why is this supposed to be. I think like what's the actual difference? Like I can't like if we go, let's go to the test target, right? And let's go to test 0, right? Now we have this. It's compiling and printing out hello world. I don't know what that is, but that's okay. What if, like, we have x equals to 7, and then we have const y, and we assign it to 7. Oh, we are forced to declare. Okay, that's a difference that I noticed. That we are forced to explicitly state the type, because the type cannot be changed. Okay. Now, what if I declare this? I cannot do that. I don't know. Let me just try to compile this. Paris. Huh? What the hell? Oh, this is a constant pattern. The thing I like, and that I noticed on months ago, that the compiler actually tells you and tries to help you with issues, and that's another advantage compared to C++. And I'm not gonna lie, sometimes C++ errors are fucking horrible. There are like walls of text that are just a chain reaction of errors, but you get there and it's really, really unreadable. It's really unreadable. But that's cool. That's cool. So we have this. That's the thing I noticed. Like you can shadow this X and you can like not explicitly state the type. Meanwhile, the const requires you to explicitly give the type of the value, and you cannot even foreshadow this, or how is it called? Now we have the data types. That's the unsigned 32. And then you can also parse a string like that. Ah, that's interesting. Keep in mind that Rust is a statically typed language, which means that it must know the types of all variables that compile time. Is that the same thing to C, C++? Kind of. Yeah, it's kind of the same thing, but in C and C++ you can actually cast. In C++ there is also the concept of dynamic cast, which is really cool. The compiler can usually infer what type. Okay. In cases many types of such we convert a string to a numeric using parse. Yeah. But this time we have unsigned 32, right? If we don't add the unsigned 32 type notation shown in the preceding card, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Oh, that's why. Yeah. It's probably like this. And probably because this has multiple return values. And based on the type of the variable, you have some return values, right? And if you don't specify anything, like how is it supposed to know, right? And we have, what is this? What is arch? Arch is an integer, right? I sides, U sides. What does that mean? I'm a bit confused, honestly. What is arch? Hold on. Is it? Oh, it depends on the architecture of the computer your program is running on. Oh, that's cool. That's cool. That's another thing that C and C++ doesn't have apparently. Like they kinda have with the probably something defined in the standard int header file, but they don't have something like this, right? So then we have number of literals, then we have the hexadecimal. Oh, this is the way we can show, like we can. These are the literals, right? And what does the underscore mean? This thing is also in the and in C and C++. I just don't understand what this underscore means. Probably separating like every 3 digits. In C++, we can actually use a single quotation mark, which is more intuitive. Then we have an integer overflow. Yeah, it will. If we have an integer overflow, we have a panic. Okay. Oh. So there we also have a panic. Like this panic is uses the term panicking when a program exits with an error. We discuss about panics. Wow, this is so unique. The value becomes one. Okay, it just how can I say, resets, right? It will be reset to 0. Like this also happens in C and C++. Yeah, we also have floating types. Okay, it's just F. Okay. And like in C and C++, it truncates the division. Now we have the Boolean value. We have the, okay, that's the explicit type notation is just column bool. Now you have a character, and this character is actually an UTF-8 character, right? Yeah, like C and C++, like mentioned before, they have ASCII, but you can actually have a lot more than ASCII, like we did it here. Like you can add an emoji, right? And this would be, and the W string will just get it. Like it will just work fine. So yeah, actually the C actually has this larger string data type. It's not intuitive like Rust, but yeah, we can unlock UTF-16 and UTF-32. Does Rust have UTF-32? So do we have wide string? Oh yes, we have. Okay, that's good. That's good. Rust also has this. So we don't really, we basically have we have another joke, right? Then we have a tuple, and that's that's another Rust. Actually, tuples are also present in C and C++. So we have tuples, right? So if we go here, like we can create let, I call it tuple, right? And then we can specify like what we have, right? We can have many types of tuple, right? And then we can assign it like 1 and 2. And that's basically how it works. But C++ also have tuples. Like you can include tuple like this, and then you have std tuple. It's a templated argument, and then we have something like this, then top, and I don't know how to assign this, honestly. Top, probably with an array notation, like 16, or I can just, don't know if I can, but probably 1 and 2. Not sure, I'm not sure if we can do this, but we have something like this. We can also check the documentation, C++, tuples, and let's see. Yeah, we have, you know, we have this. Let me just oh, if you want to get a specific thing, you have to use std get. Okay. Oh, we have to call this. So we can just do that, right? Not completely sure. Does this compile? Let's see if it does. Hold on, let me just go here and let me just try to compile this. Yeah, it compiles. So yeah, there are many ways to do that. So this is the simple one. If you want, you can just, using std tuple, and you enable this. So that's pretty much how it works. And I'm not gonna lie, it's not that bad, honestly. Like, you have tuple, you wrap the types, then you have the name, and you have this. If you wanna mark it as const, you can just do that. Like, if you wanna, like, it's not that bad. It's not that bad. And honestly, I don't know. Like, that's the actual, that's the C++ version. Oh, if we want to, we can actually simplify this. Like, you can just using i32 and 32t, and we can replace this with i32. Same thing with 8. and then we have I hate. So like C++ is really flexible, and if you want to do that, you can just, you can call this type like this. Like you can have aliases, right? And you can just do this. C++ is more free. So yeah, I don't see advantages, disadvantages for now. What if we want to get the value? The fuck? Wait, what do you mean? Oh wait, you can actually assign, like, you can actually assign variables like this. Does C++ allow this? Yes, it actually allows this. So we can do this. So I'm just gonna using because why not? So we have using std tie, and hold on, let me just write that here, and then we have std ignore like this. So we can just we have to declare variables here, like I32 v1 and then I8 v2, right? We can do that. And then we have this. We can tie this. Like we can, if we want, we can ignore this, the first result, and then we can just assign it to v2, right? And this is the tuple we want to assign, right? And then let's try to print this. And we print top. I mean v2. So what happens if we it also suggests something here, but actually I'm using this. I don't understand why it doesn't work. I don't know why, but some compilers doesn't allow you this. Okay. So we just do this and then we are fine. Okay. And then what the fuck? Wait, hold on. What the hell? How do I zoom this? Okay, why did this print a smiley face? What? I probably have to cast it to int. I don't know. I'm not sure. Let me just try to recompile this. And then we have 2. Okay. I'm not sure why, but this probably because it was treated as a character, not an integer or an integer. And that was weird, yeah. We just have to cast it to int. Yeah, it might be verbose, right? Actually, I don't think that is that verbose, but compared to Rust, this is the Rust version. Let's try to do on Rust. Let's try to do the same thing on Rust, and let's try to compare the values, right? So we cd this to test 0, right? And let's go here. So that's we have the tuple right here, right? Also, I'm gonna check if I see string because sometimes it. Okay. I must see streaming. Let me just open this. Yeah, I am. Also, thank you so much for 11 subscribers. Whoever subscribed to me right now, thank you so much. Honestly, why do wait? I don't even have a thumbnail. What the hell? Let me just fix this. Oh my god, I fucking hate when. Let me just upload this real quickly. Don't understand, like it didn't upload the. Hold on, it didn't upload the thumbnail. Like what? Let me just fix this real quickly. And okay, it's actually uploading. Right, let's just wait, but it should be okay. Yeah. And now, here we go. For some reason it didn't upload. Fucking hate when this happens, but that's okay. So we have this version, like we can okay, we can specify the type like this. Then we have a variable, right? So we have let probably x and y. Wait, no. I mean, call it a and b. And that's the tuple, right? Okay. It automatically casts this. But what if I want to ignore this? Can I just... We don't have std ignore here. No, we don't. So std ignore rust tuple. So yeah, we just this is the C++ version, and yeah, we actually have this. Uh, what the hell is this? Wait, what is this? I have no idea what that is. Um, so can we ignore? Okay, this starts to be verbose. Probably we cannot. Okay, apparently we cannot ignore this. And then when we want to print that out, can we just print B like this? No, it has to be a string. Ah, damn it. Yeah. The thing is that we have this variable and it's actually unused. Not a good thing. But that's basically the difference. Like, that's the C++ version and this is the Rust version, right? Yeah, there are advantages and disadvantages between Rust and C++. I don't think there is a better language. Like, C++ has some benefits and Rust has other benefits. Like, I don't think there is a better language between C++ and Rust. Because Rust has some, I don't know, has some flaws for what I can see so far. So let's just keep going. Then we have an array type. Okay, this is an array type, right? And I'm not gonna lie, this is confusing. Like, what is this? Like, we have I32 and then 5 and then we have 3 and 5. Oh, that's how it is initialized. Oh wait, wait, I'm dumb. I didn't look at the assign operator. So to specify the type and the size, you can pass it right here, right? So let's do the same thing with the types, right? Also, let me just run this program. Yeah, it works. Let me just, I don't wanna take this server right now. So let's keep going. We have, wait, hold on, let me just check. Oh my fucking god. Okay. So let's try to create an array, right? We call it array R1. Okay, we have to specify the type like this. So we want an array of I32 and the size is 7. Can I just do this? No. What? Oh wait. It is. Yeah. That's pretty much how it works. Can I print line array 1 of 0? I cannot. Oh my god. Okay, this is another issue. I cannot even do this because this is initialized. Oh my god. So we also have these checks, and this is compile time. Good job, Rust. Good job. So we can actually initialize it like this. Like we have the array literal like this. What if we go outside? Yeah, that's pretty normal. In C++, we also have this checks. But another thing is we can actually initialize it like this. Like this will set each element to 0. And isn't that cool? I don't know if C++ has this option. It probably has, the modern C++, but I'm not gonna lie, the Rust version is it looks that it's way more intuitive than the C++ version. Can we actually no, we cannot give partial data like this. Okay, but we can completely remove this and it will work. Yeah. I don't know why it is like this, but that's okay, that's fine. Also we have invalid array element access. Wait, hold on. What if I try to print this? Okay, that should be a good practice to mark constants as, you know, I kinda like how it enforces you to do that. And yeah, out of bounds. We actually have this safety option. In C++, you don't have this. In C and C++, probably in C++ with the standard array, but with the row array, you don't have this. In C style arrays, you just read out of bounds. It doesn't care. Like, you are free to do whatever you want. That's a good justification, but that could be a problem in certain cases. But in C++, we also have array, right? We can just using array, std array, like this, and then we have an array of int32 and the size is 7, and let's call it R, right? And then we have 1, 2, 3, 4, 5, 6, 7. What if I want to print the 7th element? Will it throw an error or a warning? Let's see what will happen. So we have, let's compile this. Oh god, it actually compiled. And what if I try to run this? Yeah, you don't have this check. You don't have. Like, even if you use the std array like this, you don't have the checks. Like, okay, we have the at. Also, we have the field. We also have the field function. So let me just. So what if we try to access this element? What will happen? Okay, at least we have something. If you use the at function, you can actually check this. But be careful, because this is a runtime error. It's not a compile error. But you still have this check. And yeah. I think, I'm not gonna lie, the Rust checks, compile time checks are better, because it actually prevents you to how can I say it, to commit this error, right? So yeah, wait, what do you mean self-promotion? Where is this self-promotion? I don't understand what does that mean. Like, where is the self-promotion? We have source bytes. Okay. Do we actually have custom emojis? Let me just check because I'm kind of curious. Yeah, we have this. We have fairies, right? That's the name. So this is we use unsigned sides usually for the index values, right? Honestly, that kinda reminds me of sides type. Yeah, in C++, it's just the sides type, right? We have we have this. So we basically wait. Is this allowed? What? Let me just let me just print this. No, it shows an error. This isn't allowed, but if you actually wrap this in another scope, it's this move is allowed. Check this. What the fuck? Um, bro, what the fuck is this? Oh, all right. I know what's happening. It just prints 2, 7, and 7 at the same line. Let me just using let me just append this. Yeah. So what we have right now is okay. Or else you kind of have the same issue right here. Like you can also have like it checks if the constants if you put a constant or a fixed value on the compile time, on the run time, if you pass a dynamic value, there will be it will panic, right? Yeah, that's pretty normal. Like you cannot prevent this. And the same thing happens here. Let me just run this. And this will print out. hell? Okay. So yeah, that's basically how it works. Like this part right here is the same as this. Like you don't have that much difference. And yeah, there are advantages and disadvantages. Right? If you read a number, you have to use trim and then parse. Yeah. Then we have functions. Right? Wait. Um, is this? What is this? Is this a tuple? What is this? And what even is this? Is a block that in this case evaluates to 4. What the fuck? Oh, wait. Wait, this is okay. The semicolon here actually means something. It's like MATLAB, right? The MATLAB language. If you put a semicolon, it just becomes a statement. If you don't, it's not a statement. Like it's also a statement, but the statement returns a value, right? We can check this with a free MATLAB online alternative. Don't remember what's the name. Wait, it's Octave Online, right? So this is pretty much how it works. Like this is how you declare. I mean, this is a matrix. This is a 2x2 matrix in MATLAB, right? If you put a semicolon, nothing will get returned. It's something like this. Like if you don't put a semicolon, you'll get the returned result and will be stored as an answer. But in this case, nothing happens. The concept is kind of the same. And then we have this no sense. Like I genuinely don't understand why they did this. Like the return value is assigned with an arrow. Like why did they do this? Like can't just they put I32 before the function name? Also, this returns 5. I know this because this isn't a statement. There is no semicolon, right? So we can just let me just zoom that out, and then let's create a function. Yeah, let's follow this example. And then we just return this. Yeah, this code is valid. Okay, we print line. Okay, we cannot pass this. It actually sucks. We have to do it like this. Oh wait, this is the C++ program. What am I doing? We have the test 0, and then we have the fuck do we have? Oh, and wait, we have an error. Oh wait, let me just let me try again, and here we go, and it prints 5. That's interesting. Yeah. Because this is simply a statement. Like, it's not a return value. Okay. That's interesting. Then we have the comment. Oh, fuck. Yeah, we have the classic comments. Do we have multi-line comments? Let's check this. Yes, we have. There are some languages that don't have multi-line comments. Like, why? Why did you not include that feature? Fuck is wrong with you? Oh, that's my lucky number. 7 is actually my lucky number. Yeah. I'm glad that Rust's lucky number is the same as mine. Then we have control flows. We have if-else statements. What the? Wait, what is this? Oh my god! Sorry, I'm not used to see if statements without parentheses. This is so weird for me. So yeah, if else statements don't have parentheses, and okay, yeah, we also have this thing right here, but this isn't a statement, right? There is no semicolon, so this thing evaluates to 5 or 6. And this kind of replaces the ternary operator. Does Rust have ternary operators? I'm not sure. Let's check it out. Rust ternary. It's just an if, right? It's just if else. As expected. So they don't need the ternary operator. Now we have the loop. And if we wanna break, we just break like this. Okay. Do we have a for loop? Okay, then we have a while loop. And then we have the for loop, like this. For element in A. That's the enhanced for, okay. Yeah, that's pretty much. Yeah, we have basic statements, and not gonna lie, the if else statement is actually smart. Then we have the ownership. Ownership is Rust's most unique feature and has deep implication for the rest of the language. It enables Rust to make a memory set of guarantees without needing a garbage collector. So it's important to understand how ownership works. In this chapter, we will talk about ownership as well as several related features, borrowing, slices, and Rust lists data out in memory. Um, isn't this? Okay. This kind of reminds me of the unique pointer shared pointer in C++, right? Probably there is probably a difference. Not sure. Let's go deep into it. Ownership is a set of rules that govern how a Rust program manages memory. Some languages have garbage collection that regularly looks for no longer used memory as the program runs. In other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership, with a set of rules that compiler checks. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Okay, that's the stack and the heap. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. That's actually C++ pointer, the modern C++ pointers, right? So we have the capacity, the length, and the first pointer of the index. Yeah. I'm gonna take a short break. I will come back in a few minutes. But I'm not gonna lie, Rust is an interesting language with some interesting features and an interesting syntax. And I'll come back later, so I'll be right back in a few minutes. And see you later.